Can you see neurons, multiple neurons and neuroglial cells in this magnification? We went over this. Let us go for higher magnification. You see clearly the cell body. Inside the cell body, cytoplasm and the nucleus. From the cell body or the soma, see the dendrites. This is the axon hillock. Remember, axon hillock is a part of the cell body, and this is axon. And when I magnify this region, you'll see axon collateral. And axon, where does it end? Where does the axon end? Say. Not that.
The pituitary gland?
Oh no. Oh no. Axon ends in axon terminals, okay? Very simple answer. Here, in the posterior pituitary, the axons that are the neurosecretory cells of hypothalamus. But there are other regions. Posterior pituitary contains the axons of the neurons that are located, cell bodies are located in the hypothalamus. But this is spinal cord. Understand? So it will make a synapse at the axon terminal with another neuron maybe. Figure that? With another neuron. Now, I'd like you to look at axon collaterals. In that case, I have to, come on. Look at the axon collaterals coming off from the axon. And let's go to here. Initial segment of axon. Here is axon hillock. This is axon hillock. Axon, initial segment of axon. Look at the nucleus. Look at these. These are neuroglial cells. Okay? This slide is over. We'll go to look at another slide. You can see the neuron cell bodies. There are several other here too. But I will focus over here because it looks nice. Let's go to next higher magnification. The purple color represents presence of RNA. So RNA containing structures will be stained. Yeah, this is a cytochemical staining. And you can clearly see the nucleus, but the nucleus, only the nucleolus of the nucleus is stained, isn't it? And no staining reaction in the nucleus because mostly nucleus contains DNA. DNA is not stained. To get that? With certain chemicals, DNA and RNA, they interact differently. RNA will give a positive reaction, DNA will give a negative reaction. So, though DNA is not stained, but through negative staining you can identify the nucleus. So let us go to even higher magnification, and it has see very well. Come on. Oh, fantastic. The beauty of microscopy, when your focus becomes bad to worse, you come in the opposite direction. Do you get that? Look here. These are Nissl bodies, or rough endoplasmic reticulum. The nucleus is stained negatively, except for nucleolus. Nucleolus contains RNA. That's why nucleolus gives a positive reaction. Even in this slide, in this preparation, you can clearly identify the axon hillock. Can you see that? And this is the axon. This is the initial segment of the axon. You can hardly see any dendrite. It doesn't mean the dendrites are not there, they're there. But the dendrites did not contain any RNA that time, particular time when it was 10. And you can see even, this is very feeble reaction. Can you see that? Even you can trace the axon up to here, but very feeble, not much RNA. You can clearly identify the axon, especially the initial segment, and also the axon hillock. So if you are asked, identify the organelles, you should write Nissl bodies, because, you may write rough endoplasmic reticulum, but I don't know if that will be an option in the word bank. But I tell you Nissl bodies, the special name for rough endoplasmic reticulum for an axon. Like muscle cell is a special cell, isn't it? What is the cytoplasm called in muscle cell?
Sarcolemma?
Sarcolemma is the muscle cell membrane.
Sarcoplasm.
There you go, sarcoplasm. Like endoplasmic reticulum in muscle cell is called sarcoplasmic reticulum. Yeah, those sarcoplasmic reticulum is the reservoir of calcium ions that you studied already.
Mm-hmm.
Okay? So some special cell, they have special names, and they have some organelles that are just given to them. Sarcoplasmic reticulum for the endoplasmic reticulum in a muscle cell. Here, the rough endoplasmic reticulum has a name, Nissl bodies. Okay? And you can also see that these neuroglial cells, they also give some positive staining to this preparation. The main feature of this neuron here, Nissl bodies. All right? We finish another slide. We have to